There is another important section of thermodynamics is to understand quasi-static processes and reversible processes. When we talk about quasi-static processes, we can first define it and we'll understand how these are carried out, or how we define ideally what a quasi-static process is. We can state these are processes in which at every instant during the process system is considered to be in equilibrium. This is the basic definition. What does it mean? Let's analyze it with the help of an example. Let us consider in a container there is a gas which is trapped under a lightweight piston. In this situation, obviously gas is exerting a pressure P onto the piston, which is balanced by the atmospheric pressure. Say we supply heat from an external source to the gas. Obviously on supplying heat, its temperature will increase. If its temperature will increase, gas molecules will have more kinetic energy, and due to high number of collisions, gas pressure will increase, due to which the piston will be displaced up. Now the most important point is to be understood here is, when the piston is displaced up, say piston is displaced by a distance delta x. Now in this situation, atmosphere is suddenly pushed away, but when the piston is displaced, here a vacuum zone is created in which the gas molecules will diffuse and fill this region uniformly, and the overall gas density will decrease. Try to understand it once again very carefully. Initially, gas was confined up to the level of this piston. When the piston is displaced up, a vacuum zone is created below the piston, and the gas molecules will diffuse in this vacuum zone, and after a short period of time, the whole gas will fill the whole volume, or we can say the volume of gas is increased. Now in this situation, the time till the gas will fill the whole volume uniformly, we cannot define the pressure and temperature in different zones of this volume. Obviously, before displacement, gas was confined to this volume, but when the piston is displaced, the molecules will drift. And during their drift, we cannot define the pressure of gas at this zone or at this zone. It will be totally, you can say, molecules are distributed in a randomized manner, and for different zones of this volume, for a short period of time or for a finite duration, we cannot define pressure as well as temperature till the gas molecules will fill the whole space uniformly. So in this duration, we can state the gas pressure and gas temperature cannot be defined, or in this short duration of time, the gas is not in its equilibrium, in the equilibrium for the whole volume. So in this period, we can never apply gas law or any other mathematical rules, because all the thermodynamic coordinates for the gas, pressure, volume, temperatures are not defined within this period of time. And if this piston is continuously being drifted away, so continuously at any instant, we cannot specify the pressure, volume, temperature, because it will take some time when piston will come to rest till the gas will be in equilibrium for the whole volume of it. So we can state, if at every instant the piston is being displaced very slowly, such that at every instant the gas is uniformly filling up the space, the process is termed as quasi-static. So we can say, in nature, only a very slow process can be approximated as quasi-static in nature. Always remember, only very slow process can be approximated as quasi-static in nature. So in general, we can state Generally, all processes in nature are non-equilibrium processes, whereas the whole analysis which we have done till now was under consideration that all the processes are quasi-static. So it is just a practical consideration, a non-idealistic consideration which we are studying. And for knowledge, it is quite important to keep in mind what exactly do we mean by quasi-static processes. In sequence, let's discuss one more aspect of quasi-static processes, that is reversible processes. When we talk about a thermodynamic process, say we discuss indicator diagram of a general process from state 1 to state 2. This path is showing us that at every instant of time there is a specific volume of gas and a specific pressure of gas. But practically we can state this graph can never be drawn because at every instant it will take some finite duration for the gas to be in equilibrium throughout its volume. But we plot it accordingly. Now if the gas is taken back to the state 1 exactly along the same path, then the process is said to be reversible in nature. But as we have studied that quasi-static processes never exist in nature, so we cannot plot the initial curve as smooth as it is drawn. So it can never be taken back according to that path which would have been drawn if the process is non-quasi-static. So always keep in mind 2 points about reversible processes. One thing is practically no process in nature is exactly reversible due to non-equilibrium in nature, which we already discussed. Another point is processes can be reversed by the same path only if it is quasi-static or at equilibrium throughout its volume at every instant of the process. So about reversible process, this is the basic idea which I am giving you, and only this qualitative idea you must keep in mind. Mathematical analysis of reversible processes out of the scope of our limitations. So right now I'm not going beyond this. You just keep in mind the basic qualitative ideas I have given you about quasi-static and reversible processes.